Hey guys, welcome in Encode lecture. My name is Philip, and in this video I will teach you how you can create Google Chrome secret game in JavaScript. So without any further waiting, let's start, and I'm pretty sure all of you are already familiar with this screen when you don't have an internet and you are in a Google Chrome browser. This is a secret game you can activate by pressing the space key, and you can then play this Dyno game. We are going to create exactly the same game, maybe with the small differences, in a JavaScript with a Phaser framework. Alright, so what you need to do, or what you need to know before you will start. Okay, so you need to have a Node.js environment installed, you need to know the basics, really basics in JavaScript, and the basics in the Phaser framework. Phaser framework is a JavaScript framework for creating games, and it's very simple to learn. You'll be able to learn it in basics of this framework in 1 hour. I have already course for this on my platform. You can find the links in the description. But even though you are not familiar with the Phaser, you can watch. This will be a pretty fast tutorial, and we'll create this game. All right, so let's start. And just to tell you right now, this is not explanatory video, so I won't go into the details. For this, I am planning to create a separate video where I will be explaining step by step how I'm creating this game. Okay, so we can start, and we can start by initialization of the initial project. So I hope you're ready. Okay, we can close this, and I can, of course, I need to activate my internet. You need to go to my initial Github repository. You can find here on this link. Also, link will be included in the description of the video. It's Yerga99/Dino Chrome clone /3/main. Okay, if you are on this screen, just click here on the commits, and let's go to the first commit. Okay, so initial commit. Let's click on this. All right, and then you will click here on browse files, and then you will be here on my initial commit. You can see this link up here. You will click here on the code, and after that you will download the zip. So this will be your initial project. Okay, so now you have a download zip downloaded. All right, you will click on this. This will open it in your downloads folder. All right, so I will close here. Let's open the terminals, of course. Let's open terminals or PowerShells if you're on a Windows, and let's go to downloads folder. Okay, so we'll go to my home directory, CD. I'm in a home, and now I will go to the downloads folder. Okay, and here I should have already a Dino Chrome game. Here is the initial commit. Okay, I will go to this folder, Dino Chrome clone. Okay, doesn't really matter. You can change the name, of course. And I will, first thing here you need to do, okay, actually I will rename it because this name is too long. It's a little bit annoying on this screen. So I will go here. I'll simply rename it for a Dino Chrome clone. All right, you will go to this folder again, Dino Chrome clone, and you will run here npm install to install all of the dependencies. The second step we'll do here, we'll open our coding editors and we'll open this folder. Okay, and I told you I will go fast. Okay, so let's open our projects, open our downloads folder. All right, downloads folder, and let's find here the date modified. Okay, Dino Chrome clone. Let's open this and this initial project. So as I told you, you should be familiar with the JavaScript basics, and Phaser framework. I mentioned Phaser framework is very simple to learn. What you will find here will be src folder, where I'm initializing this initial canvas of our project with a width height that's specified here. That's really only thing you need to know here. And the preload scene, where I'm loading all of the assets needed for this game. By the assets, I mean all of the images and the sounds. All of these images and the sounds you can find in the assets. All right, so here you can find all of these assets will be used in the game. So cactuses, obstacles, are Dyno animations, Dyno images, and all of the sounds. So all of this I already prepared for you in this initial GitHub repository. Okay, so I suppose we can go to play scene, and let's check our terminals first. Well, everything should be installed without any problems, and what you can do here is to run npm run dev. This will run development server on localhost 8000 AD. This will be your game. Okay, so let's open our browsers. Okay, and we'll go to localhost 8000 AD. All right, and on localhost 8000 AD you should see here empty screen, but when you will open development tools, so right click here, inspect, and you will check here, you should have here canvas. Okay, so here is a canvas, you can see down here, canvas with a width of 1000 pixels and height 340 pixels. Okay, so now what we want to do, we want to load here some images as the ground, as you could see in our Dino Chrome game when your internet is off, and also you would like to create our Dino character itself. Okay, so let's do it. Let's go back. We'll go to our play scene and we'll load here these images. So I'll write here this ground. All right, this will be our ground image. So let's write here this dot add. Okay, when you're in a Phaser environment, you have an option. You have all these properties and the functions available under this context when you are in a Phaser scene. All right, so we have here the function this add dot. We'll add here tile sprite. Tile sprite is the structure that can be scrolled infinitely. This will use for the ground. Now we will provide a location where you would like to put it, XY axis. I will put it on a 0, 0 for now. Then you will place the width and the height of the image. So width, I will get here width. Let's say I will also get it 0, 0. I will be changing these coordinates very soon, and I will get here image of the ground. That's how we are calling this asset ground, which you can find in a preload scene. I'm loading here image from the assets folder when there is a ground somewhere here. Here it is. We are loading this image of the ground from the assets. All right, so these are coordinates, and also I'll provide here set origin point. Origin points I'm explaining in my other video about the Phaser. You can find the links in the description as I mentioned. Origin point is 0, 0, 1 here, and also you'll load here the Dyno. It will be our Dyno image, and this will be just a sprite structure. So I'll write here this physics.add.sprite. Again, just two coordinates in this case, only for the x and the y axis in our canvas, and we'll add here Dyno-idle image, and origin point will be as well 0.1. Now let's change the coordinates here. Okay, so as I mentioned, x and the y axis. I will get here first coordinates of our canvas. You can get the canvas height and the width from this game config. So I'll get here height, I will get here width, and I will get it from a this game.config. Perfect. And I can provide these coordinates into these images. So our ground will be located on the bottom of the image. So I will get here coordinate of the 0 and the height. Then you will provide the height and the width of the image itself. So this will be a height of the image, and or actually this will be just 26 pixels, okay, for the image, because this image has a 26 pixels width, and it will go full width of the canvas. So here I will get a width. All right, I will verify it one more time. Tile sprite expecting to have an x coordinate, y coordinate, width, and the height. Okay, I have it other way around. So first should be width here, and here should be height over 26 pixels for the ground. As soon as you will save this, you should go to browser and you should see here the ground. Perfect. Now we can add here a Dyno character. You'll place Dyno character on the coordinate of the 0, and instead of the second 0, we'll provide it to the height. All right, like this, and this will put the Dyno down here. This, what you see around this Dyno, it's a colliders. You can disable them in a debug, because we are currently in a debug mode. When you will go to srcindex.js, here you can find a debug true. When you will write here false, this will disable the debugger, and also it will hide these colliders. But we'll leave them so we can see what are the boundaries of this Dyno. Okay, so basically the body size of the Dyno. All right, so let's continue. We have loaded the ground, we have loaded the Dyno on correct positions. Now what we want to do here, we would like to scroll this image of the canvas, so it looks like that we are running on the ground. You can do it very simply. You can access here the ground in update. Update function is a function that is called 60 times per second, so in 60 FPS. Okay, so this is called 60 times per second, so 60 FPS. Okay, so in every update, every call of the update, we would like to access the ground image, and we would like to provide here tile position x plus equal this some number, let's say 5 pixels. So every second or every update, the tile position of the ground will move 5 pixels. This will create this illusion here. Okay, so we would like to extract this 5, which is basically pixels, to a separate variable up here. I'll call it, let's say, game speed. Okay, so this game speed, this will be this 5 pixels, or let's provide here 10 pixels per second, and we'll get here the game speed plus this style position plus game speed. Okay, so now we will be moving faster. Perfect. All right, so let's continue and let's provide here some control to our Dyno, so we can jump, for example, and also we can perform the other activities. Okay, so let's go back. Okay, so jumping. First thing, I will access here Dyno, and I will do here a couple of improvements. I will say here that our Dyno will be colliding with the bounds of our game. Okay, so with basically with the floor of the game, which is the bottom part of the canvas. So I will write here set collider world bounds, and I will mark them to a true. I will set here gravity for this Dyno. So set gravity. So this is the strength which on the Dyno will be pulled towards the ground. So set gravity on the y direction, let's say 5,000. So whenever you will jump, you will go back down to the ground in a speed of 5,000 pixels per second. All right, and the set origin can stay the same. After that, I will create here a function. I will call it create control. So or handle inputs rather, handle inputs, which will handle the inputs I will be inputting into my keyboard or the mouse. I would like to when we will press the space key on the keyboard, I would like to jump. So I'll get this function handle inputs. Let's write here this handle inputs, not like this, but like this, all right. And in this function, I will register the space key input. You will register it like this: this.input.keyboard.on, and you will catch your event of a called key down underscore space. So whenever you will press space key, callback function I will provide here will be executed. So let's provide here arrow function inside. Okay, so whenever you will place the space key, this will be executed, and you can provide some velocity on the y direction to the Dyno. So let's write here this Dyno set velocity on the y direction. We want to go up, so we'll provide here negative velocity of 1,600 pixels. This will create a jumping effect. So when I will go back, I'll press the space, you can go up. Okay, you can see, but I can press it as many times as I want, so this will create a basically flying functionality, all right, because I am not limiting it, how many times I can place a space key, or I'm not providing any other condition. So I'll provide here, I would like to only jump whenever I'm touching the ground, okay? So in this check here, or in this input, we'll write an if statement, and I will write here if this Dyno, okay, so lowercase this Dyno body on floor. Okay, so if the Dyno is not touching the floor, simply return here and don't provide any velocity like this, and that's basically it. Now we can jump only once. Okay, when you will go back, you'll press the space key, you can jump only once whenever you are touching the floor. All right, so let's continue. Let's go back to our coding editors. And what I would like to do is to set up animation to our Dyno, so it looks like that the Dyno is running. You can set up animations like this. You will create a here function. I will call it init anims to init animations. You can provide it up here. Okay, we'll copy it. I will provide it above the handle inputs. All right, and we'll create a handle init anims. Okay, so let's say here init anims, and we'll initialize your animations. You will do it like this: this.anims.create, where you will provide a configuration object of the animation. You'll provide a key, basically identifier, under which you will identify this animation. First one will be Dyno-run. All right, then you will provide frames of the animation. So from which frames this animation will consist. You can get the frames from this anims.generate frame numbers, and you will provide here Dyno image, and you will provide here start frame will be frame number 2, and end frame will be number 3, and all of this I'm explaining also in my other video. If you don't know how it works, basically here you see I'm generating frame numbers from a Dyno image. Dyno image you can find in the preload scene. Here is a Dyno somewhere. Dyno. Okay, let me find the Dyno here. So here we are loading this Dyno image. From the Dyno-run.png. So when you will go to assets, you will find here Dyno-run.png, and we are providing the this frame and the last frame. So these two frames will be basically images which will create animation, these two frames. Okay. All right, so that's how it works. Also for other guides, don't forget you can just check my YouTube videos or my other course where I'm explaining this in much details, or after lecture where I will be explaining this step by step. Okay, so we are generating here frames from this image I showed you, frame number 3 and the 2, framing system starting from the index of 0, so that's why frame 2 and 3. Okay, so then you will put a frame rate. So under here, frame rate, and let's say this will be repeating 10 times per second, so 10 FPS. And repeat, you will write a -1, so this will repeat it in the loop. I will copy this animation because we need 2 more animations for the dyno. We'll have an animation for dyno down, so then it will be the dyno will be kneeling down. Dyno down anim, let's say, and here will be the last one, will be dyno or enemy dyno fly, enemy dash dyno dash fly. You can check all of these images in the assets if you are interested. Alright, this will be the last image will be 6 FPS. Repeat will say the same, and we will generate these frames from the different images. So this will be generated from a dyno dash down, and this one will be generated from the enemy dash bird, and also frames will be different. This one will be starting from a 0 frame and ending on a 1 frame, and this one will be starting from a 0 frame and ending on the first frame. Okay, these ones are animations, and we would like to play these animations when our dyno is running, basically. Okay, so let's go to update function down here, and I'll write here if statement. Okay, let's write here this if, and I will check if my dyno has some velocity in the upwards direction. So if it's changing position when we are jumping, you can do it like this. If this dyno dot body and a delta absolute y position is greater than 0, this means dyno is jumping. Therefore, I will access here dyno animations, and I will stop playing all of the other animations, and I will provide the frame to our dyno. The dyno set texture, and I will provide the texture of the dyno. This will basically assign me the image where the dyno is not moving. You will see it very soon. And I will write here is else statement. And this statement will be basically when the dyno is running. So I'll write here this dyno.play. And I will play here animation we have registered dyno-run, and you will provide here a true value as a second value, and this will ignore this display if the play is already, if this animation is already playing. So okay, now let's save this. When you will go back to your browsers, you should see whenever you are when you are basically running. Okay, it looks like you're running. You are playing this run animation. When you will jump, you will set the texture of the dyno, which is this static image you can see when we are jumping. Okay, like this. Oh, perfect. So far, very good. Okay, now let's create an animation when we are kneeling down, so we can go basically down with the dyno. We will see it. Let's go back. Let's register here second input. So I will copy this one here in the handle inputs. Let's make here some space, and this will be key down. But when we are pressing not the space key but the down key like this, you'll perform the same check. We want to do this only when we are on the floor, and now we want to change the height of the dyno. Okay, so to looks like that we are going down with the dyno, we'll write here this dyno.body.height. I will assign here height of the 58 pixels, and I will write here offset. Okay, body.offset on the y direction. I will write here, let's say 34. All right, I will copy this. All right, I will provide here, and body height when the dyno is in a normal height, when we are not going down, is exactly 94 pixels. So I'll write here height will be 94 pixels, and in this case when we are up, we don't need to provide any offset, so we'll write here offset 0. We need to provide only offset when we are decreasing the height, and you can notice here offset plus height is the height as when we are in a normal state, actually. Or actually not, this is 94, 92, it should be 92, something like this. So 58 plus 34 is 92. Okay, so this is the state when we are jumping, and this is the state when we are kneeling down. Let's save this, let's go back, and you will see now when I will press here down key, basically the player or the dyno is not going down yet, but you can see the position of the body is changing. Okay, you can see we are decreasing the height. Perfect. Also, we would like to, when we will leave the key of the down key, so when we'll press it, we would like to lower the height, but when we'll leave the key, we would like to go back to the original position. Okay, so let's also handle this case. You'll do it like this, simply copy this input here. All right, and let's write here a key, not key down, but a key up. So whenever you will release the key, so key up of the down, you will write here key up. So when we will leave the key, we would like to go back to the original position. Okay, so let's also handle this case. You'll do it like this, simply copy this input here. All right, and let's write here a key, not key down, but a key up. So whenever you will release the key, so key up of the down, key up of the down. We don't need to check here on the floor anything here, and we'll simply get here body height will be 92, so we'll go to original height on the offset 0 like this, and now when it will go back, okay, you can see now when it will pushing the key, you're going basically you're decreasing the body height. When you will releasing the key, you're going back to original position. All right, perfect. This is working. Now we would like to play the correct animation when we are going down. Okay, we can do it very simply. Let's write here in this else statement in an update. I will write here ternary operation, and I will check for the height of the player. I will say here if this Dyno.body.height is the lower or the equal than 58 pixels, then question mark, then play me animation that we are down. So this Dyno.play, and the animation will be Dyno-down-anim. Let's write here 1. All right, true. Okay, so ignore if playing already. And the second animation will be Dyno-run. I'll paste it here. Okay, like this. You can also modify it on the new line here and the new line here. Okay, so when the body height is lower than 58, play me down animation, otherwise just running animation. Let's take a look on this. Let's go back to our browser. Okay, and let's go down. You can see we are going down, we are going up, so everything is working correctly. All right, now the other thing, I would like to start the game differently. How we are starting now, I would like to start with from the point where the canvas, or basically the ground, is not moving. I will show it to you. I will just disable my internet for a second so I can show you the game. Okay, so let's go somewhere, doesn't really matter. All right, and let's press here. We can see we are starting from this case here. We are just not moving at all. When we'll press the space key, we will move towards. We will jump, we'll go down, we'll move maybe 30 pixels to the right, and then the game is starting. Okay, so we like to achieve this. So first we need to create some trigger that will trigger this event. Okay, let's go back here. Okay, and I will create here this trigger. So I will go up here. I will not here. Above the ground, I'll write here this. Let's call it start trigger. Okay, this physics.add.sprite here on the position of the 0, 10, and let's set here origin, set origin, okay, 0 at 1, and set it immovable, so we are not able to exchange any velocity to this item when we will hit it with the player. Okay, so let's go back. Now you will see that about the player there is this empty box. So now whenever I will hit this box, what I would like to do I would like to move this box down here on the bottom position of the Dyno. How can we do it? Okay, I will set here overlap between the box and between the Dyno. Okay, so let me write here a new function. We'll call it this init start trigger. Okay, let's copy this function and let's init it here. Let's say init start trigger down here. Oops. Init start trigger, let's provide here brackets, curly brackets, and here I'll write this this physics.add.overlap, and overlap between this start trigger and between this .dyno. Let's provide here a callback function, normal arrow function, and as the third value we'll provide here a null and this context. Okay, like this. Now whenever you will hit the box, let's write here alert hello. Okay, like this. Let's go back. Now whenever you will hit the box, you will run this trigger. Okay, you can see hello here. Okay, let's continue. Let's go back. Okay, first I would like to check if I'm hitting the box when the box is in an upward position. So I will check of the position of the box. So I'll write here if this start trigger and the Y position has a 10. So it has a position on the Y-axis of a 10 pixels. So don't forget we set it here 10 pixels on the Y position for a start trigger. Then reposition me start trigger. You can do it like this. This start trigger dot body dot reset body, or just a reset. Where is the function? Here, reset. All right, reset, and reset the position of this on the 0, and this game. Let's extract here the width and the height up here. So let's write your const in the curly brackets. Let's get your width and the height, and you can extract it from a this game.config. All right, and then let's provide me here the height position. So it will move it to the bottom part of the map, and then simply written from here. Now let's see what will happen. Let's save this now. Let's go back to our browsers. Okay, so let me refresh the browser. Okay, let's see console. Actually, nothing is happening because we didn't console anything, but let's see here. Okay, so I will hit it from up and then it will appear down here. Okay, now we can display console log that we are hitting this. So console log, okay, hitting the box. Okay. Okay, so now when we will hit the box, we should see here hitting the box. So see hitting the box and hitting the box whenever also when we are overlapping when the box is already down. So we are executing it already 400 times, 500 times, and we don't want to happen this. We would like to execute it only once. So as soon as we'll hit this box, when we will go to the original position, I will say here this start trigger. Okay, let's write here this start trigger, disable body, and you will write here true to disable it completely. Like this, disable body, and now we will execute it only when you are hitting it on an upward position and downwards once. Like this, jump up, and now you can see, or I just remove the console logs, okay. So let's write here console log one more time. Sorry for confusion, I don't know why I removed it. Let's console log here something. Okay, let's save this, let's go back. All right, let's step up here, go down, and you can see we are executing it only once. Here is AAA. Okay, so now let's continue and actually let's start our game normally as I showed you in example here. Okay, let's go back to our coding editors. And first of all, we will get here ground, and I will set here original position of the ground will be height and the width. So width will be not the full width of the canvas, but let's say 88 pixels. I will introduce here a new variable. I will call it has game started or is game running, and I will say here it will be false. By default will be false. I will access this variable, this is game running. I will go down into update function, and I will say here if this game is not running, if it's not running, this is game running, simply return and don't execute update down functionality here. Okay, now when we will start, we are starting in this position here. Okay, so nothing is basically nothing is happening. Okay, so now when I will activate the trigger up and down, then we would like to start the game. So we need to initialize here some event. Okay, so let's go back. All right, let's go up here, and I will initialize here start event whenever we are disabling here body. So we are hitting it on the upward position. So let's create here some space. And let's get here a variable called start event. You can create a timed event like this. You'll access here this context time.add event. All right, and you'll write here delay. So how often will be this function will be called? Let's say it will be called 60 times per second. So 1000 millisecond, which is 1 second divided by 60. This will execute it 60 times per second. All right, so delay, you will write here loop. Let's loop here infinitely, so loop through. Let's write here callback scope. Callback scope will be scope of our class, so callback scope will be this context, and callback itself, so function which will be executed every 60 times per second. This callback will be executed 60 times per second. Okay, what we want to do in this callback, we would like to assign here to our Dyno some velocity on the x-axis. So we'll move the Dyno a little bit. So set velocity on the x, let's say 80 pixels. Okay, then we'll play here running animation. So this Dyno.play the running animation. So Dyno-run, ignore if playing. So one value, and I will say here if this ground okay, this ground.width is the less than our canvas width, okay, then increase my width of the ground. So this ground.width plus equals 17 times 2, like this. So this will go 34 pixels. Will be increasing this ground width 34 pixels. Okay, every time that the callback will be executed. All right, so now let's write here another if statement, and let's say if this ground width is already of the size of the canvas, so it's larger or equal than 1000, or we can just say that larger than the entire width of the canvas, this means we can start the game. So I'll write here, first I will verify the ground.width is the same as the width of the canvas, so I'll assign the width to the ground width. Alright, I will say here this is game running will be true, so we can run the game, and I will say here this Dyno set velocity, I will reset the velocity back to the 0, so the Dyno isn't running any longer, and I will write here start event, and I will remove this event so it will be not executed any longer. Okay, so now let's click and save this, and we can see what will happen. Okay, let's see. Alright, so we will start, we are running towards a little bit, and then we are starting the game. You can see, okay, hitting the ground, we are moving 80 pixels around, or we are moving a little bit, and after the canvas, the ground has a size of the width, we are starting the game, so we are initializing is game running to the true, and this will execute the update loop, and we can play the game. Okay, this is working, we can continue, and we need to create some obstacles in the way, because of course you can see there are some cactuses in the way, and we would like to also create some of these objects to our game. Okay, so let's go back to our coding editors, and let's initialize this. Okay, let's go back. First I will write here respawn time, so how often I would like to respawn my items, and I will initialize the respawn time to the 0. Okay, this will be time in a milliseconds. By the default it will be 0. I will scroll down here, and I will create here a new variable under Dyno. I will call it obstacles, and obstacles will be empty group for now, obstacles, and let's create here this physics.add.group. All right, this will be the group. And then we'll create here a function to place the obstacle. Okay, so let's write this function, let's say under init anims handle inputs. Here will be function place obstacle. All right, what I will do here, I will generate the number of the obstacle I would like to generate. I have prepared for you seven obstacles. First 6 obstacles are cactuses. The 7th obstacle is the pterodactyl, this bird. Okay, so I'll write here const obstacle number. So whenever I will generate, I would like to get here random number of the obstacle. Okay, from a 0 to 6 or from a 0 to 7. I cannot sure now. Okay, so let's write here math.floor math.random. All right, so we'll generate here obstacle. So it will be actually 7 obstacles plus 1, so this will be number from a 1 to the 7. Okay, so obstacle number, and then we'll get here const distance, so how far this obstacle should be generated. Okay, let's write here phaser.math.function between, and let's say this distance between the obstacles should be between 600 and 900 pixels, randomly generated. Okay, and I will console log this information. Console log obstacle number. All right, and let's console log me here distance. Perfect. Now I would like to place these obstacles, and we'll be placing these obstacles in the update function after some interval. So let's write here if statement first, and let's accumulate here some time in a respawn time. So I will write here this respawn time plus equals delta time times this game speed. This game speed, let's write here times 0.08. So that's how I configured it will be good to the respawn time for our obstacle. So delta time is the time from the last frame. This approximately 16 milliseconds. Our game speed is at 10. So 16 times 10 times 0.08. And if this response time is larger or equal than 1.5 seconds, so 1500 milliseconds, then spawn the obstacle. So this plays obstacle and a respawn time. So this respawn time will be 0. Okay, now let's save this. Let's go back. You shouldn't see here any changes, but when you will open a console, actually see here error delta is not defined. Fair enough. Let's go back. Time and a delta you can get from an update function. Just only specify here time and the delta time. Let's save this now. Back to browsers. I'm going too fast. Okay, so but I want to make it a fast tutorial, so let's press space, and whenever, okay, we have here some only time, respawn time is not defined. Okay, respawn time here should be this context, of course, this respawn time. So let's correct this context. Let's jump here, and now it should be fine, I guess. and we should see here in some intervals, this is the obstacle we would like to display, so obstacle number 6, obstacle number 4, and the distance is the second number, so 700 pixels distance, and so on, depending how we are generating it. This is a random number. Okay, so now it's time to place the obstacle and not the console logs. Okay, so let's go back. All right, and let's remove the console logs here. And let's write here a new variable. I will call it enemy, or let's call it obstacle. That's a better name, obstacle. Obstacle will initialize it only. It will be undefined for now. And I will say here, if the obstacle number is greater than 6, then I would like to create here a pterodactyl enemy. All right, so obstacle number. Otherwise, I would like to create here a cactus. All right. Okay, so let's start with the if here. So let's access here obstacle. This will be a long statement. Let's access here these obstacles we have created before. So empty group, and let's add here new obstacle. So this obstacles.create, and now we need to provide here width of the placement of the x-axis and the y-axis. For this, actually, I will get here width and the height on the canvas. So const width and the height of our canvas. So this game.config, this will get me width and the height, and I can place here this obstacle.create. So we'll be creating this on the entire width of the canvas plus the distance we are generating here. So width plus distance. The y position will be height of our canvas. All right, and then we will also generate here our image for this obstacle, and this will be our pterodactyl image. So space here, and this is under the key of the enemy dash bird. You can find it in the preload scene how the enemy bird looks like. Or actually, I will show you. Let's see assets, and here should be enemy bird. Here is enemy dash bird. So this image, this pterodactyl. Okay, so we'll go back to placing enemy bird, and enemy bird can be placed in 2 different positions. It can be placed on the little bit higher in the map and a little bit lower in the map. So I will write here 2 different heights. Let's write here const enemy height, and let's say we can have here enemy height on the 22 pixels from the ground, and also we can have a height of the 50 pixels from the ground, and we would like to decrease it from the height when we are placing these obstacles. So we'll write here height minus enemy height, and we'll generate here this height for the obstacle. So we'll get here again map.floor, and here will be map.random. All right, and here will be times 2. Okay, this is a super long statement. Okay, so here we are placing this obstacle. So maybe I will provide here on a new line here. So create on these positions, you can see here. So width plus distance, height minus enemy height, and the image we'll use for this game object will be enemy dash bird. So this pterodactyl. Okay, when we will place this item, let's access here obstacle, and let's play here animation. So let's write here play. Obstacle.play, and animation is called enemy-bird-fly, and let's provide here 1 for ignore if playing. So this will be ignoring this statement if its animation is already playing. Perfect. And also decrease the body height of the bird. So let's write here obstacle.body.height, and we'll decrease it by the 1.5. So I will get here this obstacle body height, and I will decrease it. So I will divide it by 0.5. Perfect. Otherwise, we would like to generate a cactus image. So let's write here obstacle. Let's assign here these obstacles. It's quite a long statement, right? So you can find the code in my GitHub repository, of course, if you want to copy it. So this obstacles.create. Let's access here again the width of the canvas plus the distance. This will say the same. Then we'll provide here a height of the canvas, position, and then we'll provide here a key for an obstacle and obstacle. Make sure you're getting it here right. I have a typo here. Obstacle dash $ and curly brackets, and this will get our obstacle number here. So this will be number from the 1 to 6. If you will take a look in the assets, we have actually in the preload, we are loading these cactuses like obstacle 1, obstacle 2, obstacle 3, obstacle 4, and 6. So that's why we are randomly generating this obstacle number, so which image we will provide there. Okay, so these are obstacles. Very small improvements here. I will access the obstacle.body.offset, and I will change the offset a little bit on the y direction. I will just provide here plus 10 pixels to the offset, so 10 pixels. This should be obstacle plus 10 pixels. So equals the plus 10. Okay. And also let's make these obstacles immovable. So let's write here obstacle and set immovable. All right, perfect. So let's save this. And there will be one problem here because we are not providing, we are not changing the position of the obstacles. So we will generate the obstacles, but they will be not moving towards the player. Okay, so what we need to do, let's go to our update function. And as we are changing the position of the tile position, let's also change position of every member of our obstacle group. So let's write here phaser.actions. You can access your function called increment x. You will access every member of the obstacle. So you will access these obstacles. If you want to get every member of the obstacle group, you'll get a function get children, and you will decrease the position by the game speed. So minus this game speed like this. Let's save this. Okay, let's go back to our browsers. And now when I will save jump here, we should see the obstacles moving towards the player, but the position of the obstacles is not correctly set. As I can see, the cactuses are under the ground. Okay, so we need to just change the position of our obstacles, and yeah, then it's gonna be good. Okay, so let's go back to our coding editors. The only thing we need to do, we just need to change the origin points of our obstacles. So let's write here obstacle, or we can do it also here. We can change here obstacle and set origin point. Set origin, and our origin point will be 0, 1, 0, 1 like this. Okay, let's save this now. Back here, let's jump, and now we should see the obstacles in the way. Perfect. So there's a cactuses here, and we are also always generating a different obstacle in the way of player. Perfect. So this is working great. What we need to do now, we need to create a collider between the Dyno and between the obstacle, so we can lose the game, because now we don't have a losing condition, and whenever we'll decide to go through the obstacle, we can go through the obstacle. We don't need to even jump here. Okay, so we would like to also create the collider, and I don't see here any birds generated. So maybe the condition for generating a bird is not correct, because yeah, they are not appearing on the map. So let's take a look what with the birds. Let's go back. Okay, so our number we are generating times 7 plus 1, that should be correct. Let's see our obstacle here. We are providing here mav random. Okay, that's wrong. It should be mav random. We need to call this because there's a function, and times 2 should be inside of this. So times 2 like this. So mav floor, mav random times 2. Perfect. Now it's correct. And also the other thing incorrect here is the enemy. Bird fly is the wrong name. It should be enemy dino-fly. Let's save this now. Let's go back. Okay, let's trigger here this event, and now we should see here some dinos. Okay, so let's see cactuses. Now we need to be lucky with the number of 7. So yeah, here is Dino. We can go down, and perfect. Okay, so dinos are now generated as well. We can wait also for a second one just to be sure. And yeah, here is the second one. Perfect. Okay, now we would like to create a collision between the dinos, between the Dyno and the player. Okay, so let's do it. Let's go back. Okay, so now we can move up here into our create function, and in a create I will initialize colliders. Okay, so init animations, under animation let's write the init colliders. Let's create this function init colliders up here. So init colliders, where I will create a collider between the Dyno and the obstacles. You can do it like this. This physics.add.collider. Perfect. And you will see the collider between this Dyno and these obstacles. You will provide here arrow function will be executed after these two collides, and also you'll provide here null for the fourth value, and this context like this. Perfect. So what we would like to do when these two objects collide, we would like to stop all of the physics. You'll write that it's physics.pause. You'll pause all of the physics. You will say here your game is not running anymore. So this is game running will be false. Perfect. And then you will pause all of the animations. This animes for function called pause all. This will pause all the animation, and you will say Dyno set texture. I have prepared a texture called Dyno-heart. All right, this texture here, and then you will provide the you will reset the respawn time. Respawn time will be set to the 0, back to the 0, and the game speed will be resetted back to the 0 like as well. Not the 0, to the 10. This is the default value. All right, so pause false for a running, pause all for animation, set texture, respawn time to the 0, and game speed to the 10. Perfect. Let's save this. Now we should be able to collide, and everything should be stopped. Okay, let's see. So we're going to collide, and everything will be stopped. Perfect. And also the texture of the Dyno has changed. But we need to handle also here, I didn't mention, whenever these obstacles are going out of the bounds of our canvas, they are still existing in the memory of our computer because we are not destroying this object. So they are going to the left and they are continuing, and the code is still executed. So we need to destroy these objects. How we can do it? Actually, functionality for this is very straightforward. Let's go to our update. We'll be checking on every update if the object is already out of the bounds. Okay, so let's say here under respawn time, I'll write here if statement. If, or let's do it different. Let's write like this. Let's iterate here obstacles. This obstacles.getChildren. Get children, so we'll iterate over all of the obstacles. I will write here for each and every obstacle. I will check if the position is out of the bounds. You can do it like this. If the obstacle dot get the bounds, all right, and the right position is the smaller than 0, this means it's out of the bounds, we will destroy this obstacle. We'll write here these obstacles. A function is called kill and hide, and it will provide the obstacle you would like to destroy. So obstacle here, perfect. All right, save this now, back to browsers. Okay, let's refresh, and okay, we need to verify it, right? So I will verify it like this. I will just simply write here console log, destroying obstacle, destroying. Okay, there's a typo there, but never mind it. Okay, let's go back. Okay, let's jump here. Let's open a console. Let's see game, and we should be able to see that we are destroying obstacles. So it's go left and destroying. Okay, and it's continuing destroying all the time. It's going to the left. So I guess something there is wrong. Okay, so let's go. Let's see, and destroying. Okay, that's actually not very. That's not very correct behavior I would like to have. So let's see what's wrong there. Okay, let's go back, and I will use here a slightly different function. I will just simply access here I should leave here console log, right? I will access here obstacle, and I will call here function destroy just for now. Let's see what this will say. Okay, so destroyed. Let's go back. I don't know why I have here opened two console local hosts. Okay, I will close one. Okay, so let's try now. Let's jump up, and whenever I will now jump over the obstacle, let's see, destroying only once. Destroying, perfect. So now we are correctly destroying the obstacle. Perfect. Okay, let's continue with this. What we want to happen when we will pause the game, we would like to display here that we can restart the game. So we need to have here some restart screen. Okay, let's go back to our coding editors. I know I'm saying it a lot, but we are always going back to our coding editors. Let's go up here, and let's create here a couple of game objects. Let's say under Dyno here. Okay, I'll write here this context. I'll write here game over screen, and let's write here this.add.container, and we'll place it in the width, let's say width in the middle, so width divided by 2, so half width and a half height, so height divided by 2 minus 50 pixels. Okay, and we will set it alpha, or not set anything yet. Okay, let's just write here game over screen. Now I will write here this game over text. All right, let's write here this add.image. Also, I provide this image for you. Position will be 0, 0, and game over, game dash over. All right, and the same for the restart. So restart image this add image, again 0, not 0, 0, but 0 AD pixels. This will be slightly indented, and the image is a restart image like this, restarts. And we'll set it to interactive. When you will set something interactive, you can interact with this as with the input. So set interactive, so we can click on this item and this will trigger the event. Okay, so set interactive. Then you will access your container, so this game over screen, and you will write here function add, and you can provide here array of the items you would like to add into this container. So this game over text and this restart. All right, let's save this. Let's take a look. Okay, and now we are displaying here game over text by default. So I will say it like this. I will set here set alpha to be 0. So now it will be hidden. And I would like to display it only when we lose the game. Okay, let's go back. So whenever we are losing the game, whenever we are colliding here with the obstacle, so let's write here this game over screen and set alpha back to the 1 like this. Okay, let's go back now. Okay, let's trigger the start and let's collide with the items, and now we should display here our game over screen. Okay, game over screen is here. Now what we want to happen when we'll press here this restart button, we would like to restart the game. So let's handle this input. All right, so I'll write here this function in a handle input. So let's go to handle inputs here, and let's write here, let's access here restart. So this restart, restart, okay, that's correct, on, and you can react here to event called pointer down. So whenever you will click on this will be executed. You will provide your callback function. This callback function will be executed after you will click on the restart, and now we need to handle here lots of things. Okay, so what we want to happen when we will restart the game. We'll access here our Dyno. We'll set the velocity of the Dyno on the y-axis to the 0 in the case the Dyno is jumped in the sky. It was in the middle of the jump when we have lost the game. So we'll set it back to the 0 velocity on the y. I will access here this Dyno.body.height. I will reset the height of the Dyno back to the 92 pixels in the case we have been down with the Dyno. And also I will access here offset, and offset on the y position I will reset back to the 0. Okay, so I'm basically resetting all of my initial state. Okay, I will say here this physics.resume because I have paused them before. Okay, then I will access here my obstacles. I will reset all of the obstacles. These obstacles clear. You will access here true and true value for this. Okay, so this will remove all of the obstacles from the obstacles group. Then we'll start the game. So this is game running. We'll run it back to the true. We'll say here this game over screen. We'll hide it again. So set alpha back to the 0. All right, and we will continue all the animation. So this anims.resume all, and like this. Okay, now we can save this, verify these values. Let's go back to our browsers. Okay, let's refresh. Let's jump up here and let's lose the game. So let's collide with something. Let's click here game over, and we are starting again. Perfect, so this is working. As you can see, we'll jump on top of this. Let's game over. We're going down, and everything is going as before. Perfect. So now what we need to do, we need to keep track of the score. So as the game is running, we need to increment the score, and we need to display also the score. Let's do it now. Let's go back. All right, so where we'll initialize this, let's go up here. I will write here this score will be 0. I'll create here score text. So let's write here this score text will be actual text. So this add.text, which will display in our game on the coordinates of the width on the 0 on the y-axis. Perfect. The text will be simply 0000000 5 zeros. That's how it is in the original game, and then a couple of options for the fields. So this will be the font color, hexadecimal color, hash symbol here, and this will be 535353 535353. This is a grayish color. I'm missing here some brackets, something happened. All right, and then we'll specify here font. All right, and the font will be 900 for the weight of the font. Then the size of the font will be 35 pixels. Sorry, it's not visible very for you. I'll place it here, 35 pixels, and the font will be Courier. All right, and the resolution, so it will more pixelated. I will write here resolution to be 5. Resolution will be 5, like this. Perfect. Now let's save this. Let's go. Let's also write here set origin. I forgot. So set origin, and set origin will be 1 0. Okay, let's save this. Now you should see here we are providing this score. Now we need to increment this score. Okay, let's increment the score. So I will create here a separate function for this. I will write here this handle score. All right, and in the handle score function, we'll be incrementing the score. So I'll copy it. Let's go up here, down here, and let's create it here. Let's say this handle score. All right, and I will create here a time event. So this event will be executed, let's say 10 times per second. So this time at event, let's schedule this event. Let's write here delay. So 10 times per second. This means 1000 milliseconds, which is 1 second divided by 10. All right, loop, let's write here, this will be looping infinitely. Callback scope will be this context of our class, and the callback function which will be executed every time this event will be run. All right, so like this, callback. First thing we would like to execute this event, we would like to continue in the execution of the function only when game is running. So I'll write here if this game is not running, if this is game not running, let's write here if statement, of course. If this game is not running, then simply return. Don't forget exclamation mark in the front of this. If this game is not running, then simply return. Otherwise, increment score by 1, so score plus plus. Let's increment also game speed, so we'll go gradually up in the speed of the game. So game speed, not plus plus, this would be too fast. Let's increment it plus equals, and let's say 0.01. Okay, so slightly increment of the game speed, and then score is done, and we will anyhow, okay, let's see it now. Okay, so I will save this. Okay, we shouldn't see here any change, but I'm looking for errors in the console. There are no errors. Okay, so now what we need to do, we need to display this text on the screen, and this will be slightly funky function for this. So let's first write it, and then you can debug it by yourself. So let's write here score. Remember, our score is the number. We need to transform it into the 5-digit text as you are seeing it here. So I will get here functions score array. Okay, we'll create here array. Okay, from our score. So array from the string string of this score. Okay, so I'm transforming the score text into the score, and I'm transforming it into the array, which is very interesting, of a number here. All right, then I will write here simply iteration for let I is equal to the 0, I is less than the 5 minus string defined. Okay, it's not very visible. 5 minus string. All right, and here this score dot length. All right, and then we'll increment here I++, where is the end of the bracket here? Let's write here I++, and like this. Okay, I have here some problem with the brackets. Okay, I don't like when this happens. So this string here is missing 1 bracket, 2nd bracket. Okay, I will rewrite it completely. Okay, because I have here now a lot of typos with the brackets. Okay, so one more time, just a simple for loop. All right, so let y is equal to the 0, I is smaller than the 5 because we would like to display 5 digits, then the stringified, let's write here string, this score dot length, and now I++, now it's correct like this. Okay, so verify this statement, and then simply to the remaining digits, let's write here score dot unshift, and let's add their zeros, and then simply write here this score text, set text, and we'll set here text of our score dot join because now it's array, and we'll create it from here. We will create from it the string text like this. Okay, you can place the debugger here if you're not sure how this works. Okay, and let's see. So you'll be running the game, and now we are incrementing the score like this. So we create basically this functionality because remember, score is just a digital. This is just a number. Is just a number like a 10, 12, 13, 14, but we need to transform it into the 5-digit string. So we need to first we need to transform our score into the string. Okay, actually into the array. Okay, so we are creating here array. We are creating this array from this score. this will create an array like this. I will write here debugger, okay, so you'll see it actually on your own eyes, because it's maybe slightly difficult to grasp this. So I will jump here. Okay, so this is one of the things I need to explain you. So we are getting here score is just a number 1, you will see, and now when I will transform this, score will be array with the number of the 1. What I'm doing now, I'm iterating over this, so we need to create a 5-digit numbers, so I need to provide the remaining zeros in the front of the 1. This will create a 0, 0, 0, 0, 1. So I'm iterating here, remaining the times of the length of the score. So score length is a 1 of this array, so I will just simply iterate here. Okay, maybe I'm doing it a little bit difficult right here. Maybe we could maybe we could simplify this like this. I will just write here simply score score.length, and this should do a job, I guess. Okay, let me see, score.length. Let's jump here, and this should work the same. Oh, okay, no. Okay, because we have it here, only 1 digit, but we need to get the actual number of the characters in the string, so this score.length. Okay, never mind, guys, just debug this. Now you should iterate here 4 more times, and you should add the zeros in the front of the score, and then you will simply transform this array back to the string with the function score.join, and this will create from the array again string of these 5-digit numbers. So you can simply place a debugger, and you can debug it by yourself, but we need to continue because we are already spending a lot of time here. So score now works. What we would like to keep now is a high score of the player. So whenever we will lose the game, we will also keep the high score of the previous game. So let's do it now. Let's go back. Okay, let's go up here into create function, create score text. Let's copy this over and let's create under this high score. So this, let's write here high score text, high score text. Okay, this can stay the same, 0, 0, 0, courier, resolution 5, set origin. Also one improvement here, I will set here alpha. Set alpha to the 0, so it will not display by default when we'll run the game, so set alpha 0, and also for the second item, set alpha 0. And also let's set the alpha to the 1 when we are running the game, so we'll get here score text. Alright, when we are running the game, let's see, our event. Let's go down here, not place obstacles, not update, okay, it should be somewhere up here. Handle score, up. Let's init start trigger, so here it is, and in a callback when we are starting the game, I will say here this dot score text set alpha to be 1. Alright, and we'll hide it when we'll restart the game, so I'll copy this, and when we'll collide with the colliders here, so I'll say here this score text set alpha back to the 0. Or we don't need to hide it actually. Alright, my mistake, so we'll remove this. Let's save this now, let's see it. Okay, let's trigger this, we are running the game, we are displaying the score. Let's collide with the enemy, let's restart the game. Okay, we are... for the other thing, we need to restart the score back to the 0 when we will restart the game. So let's get back. Okay, let's write here, this score is equal to the 0. Okay, now it should be fine, so I will go back here, I will start the game, and after I will restart, we should go back to the score 0, and after that we'll keep the best score, so we'll restart, we are going to 0, perfect. Let's continue, let's go back. Okay, we'll do it in init colliders. Whenever we'll collide, we would like to check if the high score is the greater as our current score. But first I'll get a position of our high score. We will just simply get here high score text, X position, and you will just move it to, on the left side from the scored text. So score text on the X position minus this score text dot width minus 20, so that will position this on the left side from the score text, and I will verify if the high score is greater than my current score. So I will get here a variable called high score. Alright, we'll get here this high score text. Okay, we will extract the text from the high score text. We'll get here a substring of the last 5 digits. So we'll get here a substring from this high score text. I'm making a lot of typos here. Okay, so let's correct this out. This high score text dot length minus 5. Okay, so we will get the digit we need. Okay, so we have a 5 digit and last digit is a 23. We would like to get this digit of a 23 here on the high score. Okay, so we have a high score. Then we'll get here current score, so we'll get here new score, so new score, and we'll verify if the high score is greater than our the previous score. Okay, so we'll get here again a number, this current score text is greater than the number of the our high score. Okay, so let's get here high score. Okay, in this, if this is the case, question mark, then this get me here this score text, otherwise get me here high score like this. Okay, and then we'll set the text, so this high score text dot set text. All right, I will mark here as a high score, so hy plus and new score here, new score. All right, okay, and this high score text and set alpha to the 1 here. Okay, so display the high score. Okay, let's save this now. Let's see if this will work. Let's verify this code. Let's start playing game. Let's do some high score. So I will jump from some obstacles. Let's say this one. Okay, and we are displaying high score. Let's refresh. High score stay here. We are restarting the new score. So let's see when we'll hit it now. We have beat. Okay, so we are displaying here still high. Okay, second high here. Okay, that's not very good. So we should restart this text completely. Okay, let's go back to our congators. Okay, what we need to do, we need to access here high score text dot length here. All right, let's save. Let's go back to our browsers. Now it should be correct. So refresh. Let's play the game. Let's create here high score. So let's collide with some object. The high score, let's refresh and let's collide again. Okay, so let's beat the score. Okay, let's refresh and the 46 is stayed here because we are still very worse in the second round. Let's create here some best high score. Okay, and now 81, refresh, and yeah, it's working correctly. Alright guys, so now I will handle some corner cases, but you can see when you will refresh the game, you can still go down. For example, here you can change the body of the Dyno when they will jump like this. Okay, it's actually working, but let's verify. Let's correct our inputs. So, for example, whenever I will start the game and I'm running these first 80 pixels, I'm not able to jump, for example. So we will wait until the game is actually running. All right, let's do it. Let's go back to our colligators. Let's handle this event. So let's scroll down, down, down. When we are handling our event, so handle inputs on the space key, I will write here additional condition. I'll write here or statement, and I will write here if this dyno.body.velocity on the x is greater than 0, then simply return me here. Okay, we'll verify these statements. So go down. Okay, or is this game not running? So this is a game running, so if the game is not running, we cannot go down. Okay, let's save this now. Okay, now when I will jump here, I cannot jump the second time until the game is actually running. Okay, and we cannot go down also here. Perfect, so this is working. Amazing. Alright, so now let's add here some environment, because on original game we are displaying the clouds in the background. So let's add these clouds, but basically you can see the game is already finished, is working just great. Okay, so let's go back to our code editors and let's do an environment. Okay, so I will go up here to our create function and we'll create here environment group. Okay, let's say down here, so I'll write here this context, we'll call here an environment. All right, this dot add dot group. All right, we'll add access here this environment dot add multiple. We'll add here multiple objects into the environment group, and we'll add here this dot add dot image on the coordinates of the width divided by 2. And this will be the X position, Y position will be 170, I don't know why, but that's a good position, you will see. Then the cloud, so add the cloud, and we'll add the 3 clouds, but we'll change the position slightly. Here will be width minus 88 pixels, and the 80 pixels on the Y direction, and here will be width divided by 1.3, again interesting number, but you can figure it out, these numbers by yourself, whenever you want to position your clouds. All right, and then we'll set the alpha of this environment to be 0. So set alpha to be 0, and we'll display them only when the game will start. Okay, so let's find here our trigger event. So init start trigger, and when the game will start, so down here we'll access here this environment, we'll set here alpha to the 1, and we'll display here some clouds. Okay, so we need to display the clouds positions, so let's go down here to the update function. All right, update, and in here I will copy this function here like this, and we'll increment here all of the environment childs, and the speed will be slightly different, will be much slower. I will write here, this will be minus 0.5 pixels each update call. All right, let's save, let's go back, let's start the game. Now we should see here clouds which moving slowly to the left side. Let's increase the speed to for the sake of this example, for 5.5, it will be much faster. Whenever these clouds will run outside of the canvas, we are not ever displaying them again. So whenever we are going out of the bounds again, we would like to restart the position of the clouds, okay? Back here, and same as we are checking here with the for each, let's do a same check. For the environment, I will copy this. I will write here this environment get children. We'll get here env. We are checking for the env bounds is smaller than the 0. Then restart the position. Let's write here env.xPosition. And let's get here our game width. So this game, the game config.width plus 30 pixels. So this will restart the position on the right side of the canvas. And also we can remove this console log here. Okay, let's see. Now let's go back. Let's start the game. Let's see. Now we should be running in the loop. Yeah, perfect. Okay, clouds are here. What we need to do now? Let's take a look actually, because I forgot. We need to decrease the speed of this. 5.5 is too fast, so let's write here minus 0.5 as we had it before. And now it's time to add some sounds to our game. So let's go up to our create function. Let's see here, and let's add here some sounds. Okay, so let's say we'll initialize them here. I'll create here this, I'll call it a jump sound. All right, let's provide here some configuration. We will add a sound like this sound dot add the sound under the key of the jump. We already loaded this in a preload scene. Okay, and a volume, it's your optional volume, but I am going with a 0.5 with the volume. I will copy it two more times, and I will create here a hit sound and also reach sound. All right, and we'll get here the animation of the hit, let's say, sound of the hit, and here will be reach, and the volume will stay the same. So you can now guess. Let's write here jump sound first, or a hit sound. Let's see what we'll find first here. Let's scroll down. So when we are colliding, let's write here this hit sound dot play. This will play the hit sound. Let's go down again. Start trigger, we don't need to handle here anything, animations, we don't need to do anything. Handle score, yeah, here we'll do if statement. And I'll write here the every 100 score, I would like to display the reach sound. So if this score modulo operator, so percent sign divided by 100, it's equal to a 0. So every 100 incrementation, let's play here this reach sound. So this reach sound dot play like this. All right, now we'll go to handle inputs. When we are pressing the space key, we are jumping. So let's write here this jump sound dot play like this. Let's save this now, and let's see what will happen. Okay, so back here, you can hear it. I think it's loud enough. Hitting, and we are going again. Now let's try to reach the 100 score. So we'll go over 100, and let's see. So 67. Oops, I cannot go even in my own game through the score. Okay, so let's see. Okay, let's try to win this. Okay, perfect. Another thing in the original game, the score is a little bit changing the colors from the. It's creating a flashing animation. You'll see. Okay, so let's go back to our colligators and let's create this flashing animation. So whenever we are incrementing score by 100 here, let's write here this twins.add, and let's put here configuration object variable target your text. So targets will be this dot score text. You will say here duration, let's say duration will be 100 milliseconds, and the repeat, you will repeat this animation 3 times, and the alpha, you will change the alpha to the 0, and you will write here yo-yo to the be true. This will be animation going from the alpha 0 to the alpha 1 with the yo-yo. Okay, so we'll be changing the score text alpha between the 0 and the 1 3 times. Okay, let's go, and let's go to 100. Okay, hope this is not too high score because it's hard to get there. All right, so 70, 80, 90, okay. Now you can see this animation was there. Okay, so what's left here? Maybe some small improvements. For example, first I will disable these colliders. I don't think we need to display them. Or before, maybe we can change the size of our player, because I think the width of the player is too big. I think we can decrease it to half size, because the collider size is, I think it's too large. Okay, so let's go back. Okay, let's see. So Dyno here, up here, let's write here set body size. Oops, like this, and let's say the body size will be 44 pixels in the width and 92 pixels in the height, just in case. And also let's write here set depth. Set depth to be 1, so the Dyno will be always on the top layer whenever we are hitting the something. Okay, so we can see the width is much lower. Hitting perfect. I think it's working great. Alright guys, so that should be done. Now we can disable Debugger. I guess it's finally time to disable Debugger. Let's go back. Let's go to our index.js file and let's disable Debugger. So right here false for Debugger. Let's save. Back here. Let's run it. Oh, one thing I noticed here, you can see when we are jumping, there is this texture under the player. We need to remove this texture. So let's go back. All right, so new play scene. Whenever you are jumping, let's find here jump. So handle input somewhere down here, right? So handle score, handle inputs. Not this one. Let's see, keyboard space here. Okay, so what we need to do here, just simply this Dyno set texture, and texture will be from the Dyno image, and the texture number 0. Okay, let's save this. Okay, now when you're jumping, you can see you're jumping normally. Perfect. Now that's the correct how it looks like in original game. Okay, guys, and you just created your Dyno game, the clone of the official Google Chrome game. And of course you can do lots of improvements. Now you can change a lot of values, difficulty of the game, small improvements, but you basically create your game super fast, and you can see how Phaser 3 is, how powerful it is. And for example, now you can publish this game on the Facebook Instant Games. I don't know, really, you need to check the license if you can publish the original game of the Google Chrome. You maybe need to do some changes before that, but I have also videos for this and also courses how to publish the games on a Facebook Instant Game market. Okay, I will just check if everything is fine here. I think we don't have any debuggers, any console logs. Let's see the lines of code. There's a 284 lines. Guys, if you would like, if you be interested to see the step-by-step guide how I'm creating this with a much deeper explanation, just let me know in the comment sections. If you like the video, press the like button, and please check my courses where I have a full Phaser courses in the description of the video on Eincode Academy website. That should be it, and I hope to see you in some of my other courses. Cheers, guys.